Okay, my name is Stephen Taylor. My name is Ray Scheifler, and this is our ECE631 final project. We have built an OBD reader. Now we'll begin this presentation by going over the hardware and software interface. The first thing we note with the hardware is the plug that goes to the car. This is a standard DB9 because I acquired a OBD port to DB9 connector. Just behind that is this CAN transceiver, which takes the logic level signals from the microcontroller and converts them into the physical layer standard for the CAN bus. Note that this jumper is not present. This is if we want to use this on another application. You can insert a jumper and have the proper 120 ohm termination on the CAN bus. The OBD standard says that we should not be terminating, but I wanted that feature for other purposes. The main microcontroller is running right here. It is handling all of these signals. Most notably for the OBD side of things, every 100 milliseconds it toggles an LED and signals a CAN message sent. The other LED will toggle when a message is received. These messages are then parsed and put into a buffer that Raul will discuss with his SD card.
So once Ray is writing into a 1024 byte buffer, every 512 bytes we will write this out to an SD card. We decided to go with a FAT16 implementation interface to the SD card so that once we're finished writing the data, you can pull the SD card out and take it into your laptop to look at the data afterwards. The SD card interface is talked to via using SPI, which is built into the actual SD card. You can see our pin head out here. And every time I write a message, I will toggle this LED. It'll blink saying that there's actually being access to the SD card. And after that, we can press this button right here whenever we're done with recording the data. This LED will turn on with the other one staying off, noting that it's safe to pull the SD card, and we can take it to parse our data afterwards.
The final feature that we have is this pin header here, which is the connector to a PIC Kit 3 or PIC Kit 2, so that we can do in-circuit debugging of our microcontroller. If we want to add further features in the future, it is very easy to do with the programming interface.
And after this, we will take you outside and show you around of the board actually working.
Now that we've seen how the board is laid out, let's look at how it actually works with the car. All cars since some date in the past have been required to have an OBD port on them. And it is generally located somewhere underneath the steering column. Mine happens to be right here. This is an OBD cable. It's a standard connector that plugs into it, giving us a DB9 end over here, which will then connect into the board. Now let's hop in and take it up for a spin.
So here we're demonstrating the fact that the board is actually working. Now the process of actually connecting the board to the car is as follows. First you want to actually turn on the car so that you've got power to OBD. Then once you've got power, you plug in the cable as shown here, and then you'll see the blinking LEDs and you're good to drive. As we drive around the block, it is taking measurements. Here we've reached our final destination with all of our data in place. Go back to the board, press the release button, safe to remove, and then unplug the OBD port. And shut off the car.
Now that we have recorded the data from the car, we come inside and we process it on the computer. Here you can see the beginnings of the MATLAB script that plots it. It pulls the data bytes from the SD card, and it gives an out, and it plots at the bottom. Over on the other screen we see the actual plots from the car. This was not taken from the trip that you saw in the video, but from another one. You can see my speed versus time, my miles per gallon over time, and my mass airflow. Note that when I sharply accelerate, the mass airflow spikes because the car is using more fuel. And when I'm decelerating, there are spikes in the miles per gallon because the mass airflow is low and the speed is still high.
Hope you enjoyed the presentation.